Oop. Hold on. Sorry. Ooh, that's bad. Okay, sorry. Hello. Okay, hello. We'll get started. That's a bad way to start. All right. Sorry for the delay. Okay, so first of all, hello. Great to see you guys again. Wait, are we recording? Okay. Sorry for the delay. The other class went over. Well, so the first thing is I'm saying hello. So now what would be great, especially for points and all that, if you can hear me at all and you put like hello in the, good morning. Thank you. Exactly what Alfred. Thank you. Good morning, Alfred. I mean, I think it's the afternoon, but yes, thank you. Remember, that's a great thing to do. First of all, that helps me know that he can hear me. Or see me. Good morning, Brian. Thank you. And good morning. And then second of all, I get to say hello to you and maybe and every single one of you, especially who's quiet. Like when it comes time to submit for the 5 points tonight, you just have to write down, I said good morning in the chat or hello in the chat, and boom, there's your 5 points. Also, it makes us all be more human. So I'm going to do this every time, like literally. Good morning, Alfred. Good morning, Brian. Good morning, even though I think it is afternoon, but good morning. I'm sorry. Good morning, Brandon. Hello, Karen. Hello, Gabriella. Good morning, Genesis. Hello, good afternoon, Sonam. Good morning. Thank you for telling me you can hear me, Roger. Also, this is a way I'm still learning your names. Please correct me when I'm incorrect about your name. Hello, Sydney. Good afternoon, Samantha. Hello, Yana. Yanali. Wait. Or Yaneli. You're going to tell me. I think it's Yaneli, but tell me if that's wrong.
It's Yaneli.
Yaneli, sorry, Yaneli. And you're not in any way related. I mean, this is ridiculous. You're not related to Stephen Bermeo, right?
No.
Right. Okay. Neither am I. Okay. We have something in common. All right. Awesome. Hello, Ariana. Wait, Yaneli. Okay. Good morning, Joran. Oh, more people coming. Sorry. Hold on. Okay. Good morning. No, good morning, Joran. Yeah, I think it's Joran. You'll tell me if I'm wrong. Hello, Kaya. Hello, Erica. Okay. So that I'm going to do that. Oh, wait, that was someone else. Sorry. Where did it just go? Oh, I got it. Okay, good. Thank you. Awesome. Okay. Believe it or not, we're going to do that every time. Like you're going to say hello to me. I'm going to say hello to you. I mean, you don't have to, but you get points and it's a way of blah, blah, blah. But it'll go faster and faster every single time. I mean, every class is going to be a higher ratio of actual physics to everything else. But right now we're still getting to know each other and get to know the system. So forgive me that there's still like, we're still working all this stuff out. So, but we will get to physics in a minute. So hello. Awesome. And there's a video. Oh, I almost saw a video. Yes, I see a video. Thank you. That's awesome. She just got more points for that. We're going to talk about that. I mean, we're not going to talk about her, but we're going to talk about the points and the video and all that in a second. So thank you, Emanuela. I totally appreciate it. And even if you turned it off right now, you would not lose anything. So great. Okay. And thank you, Brian, for the avatar. And thank you, Alfred. And thank you, Yaneli. Oh, and Andre. Oh, I didn't even see you. Did I say hello to Andre? Okay. Hello. Am I saying it right? Andre. Okay.
You can say Andrew instead.
Say it one more time. Sorry. Do it one more time.
You can say Andrew instead.
Oh, Andrew. Okay. Thank you. Okay. Awesome. So thank you for the video, for showing video. And hello, and okay, I think, have I said hello to everybody? So we're gonna do this hello thing every time. I know it's crazy, but like we got to be a class as much as we can be a class, even electronically. Okay, have I said hello to everybody? I think I have. Now we're gonna start doing some more physics today. Whoop, that's not what I meant. Hold on. And I know someone's here. I'll get them 1 second. Okay. Who's that? Someone's here. Okay. So we're going to get just talking about, we're going to start going over homework 1 today. We will, but bear with me forgive me for a couple of minutes, just still typical logistics and, you know, getting to know the class type items. Hold on 1 second. Sorry. Okay. Oh, hello, Jonathan. Oh, and thank you. Hello, Jonathan. All right. Awesome. Oh, wait, is that another video? Awesome. Thank you. Okay. So I'm going to just start reminding you or clarifying items that we want to know about how the class works. Again, one thing is, as you see, I talk a lot, I use a lot of words, I speak fast. At any time you want to just put a question in the chat saying like, wait, can you get to homework 1, please? Or wait, I wasn't clear on blah, 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 blah. You can stop me with a question in the chat. If you're at all nervous about it, you could put it in the direct chat. But I mean, the chat is pinned to my screen. So please, I'd rather be addressing things that you need than just talking. But assuming you're okay, here's like where we are in the class. So first of all, like homework 1 of the regular physics homework 1 NumberLine was technically due like the minute this class started, right? Technically it was due for class. All the regular physics homeworks, not participation homeworks, but like physics homeworks that look like problem solving, they're technically due at the beginning of a given class. If you turned in the homework, even if you turn in the homework on time, you automatically get a huge number of the points, like right off the bat. Like even before I even look at it, you get a ton of points for just even turning it in on time if it looks like a proper document and all that. If you don't turn it on time, you can still get a bunch of points, especially at this point in the semester. Like I think most of you have turned it in, and thank you very much. Even if you haven't, even though we're going to start going over it today, I want to make it clear you should still do it, and you'll still get most of the points. And it's not a competition. So those of you who did do it on time, you definitely did not waste your time. I can assure you of that. But second of all, if you happen to have, so just do the homework is point number 1. But number 2, almost more to the point, if you already turned it in like even before an hour before class, then it's very possible you've already gotten a lot of the points and you might have even gotten feedback already. Now that's not always, I'm going to get less and less efficient as the semester goes on. But what I'm here today to tell you is I'm here to give a lot of general feedback and instructions about how to do the homework. And I'm here to break down the code for feedback so that in the future, it'll take very few letters or words from me to you for me to tell you what might be missing in the future. What I'm saying is this: if you've already turned in homework and you even got it back, if you did not get all of the points, you are still absolutely in a position to get all the points. Like no, everybody still has a perfect score in this class, or still can get a perfect score. If you didn't get all the points, it's not a percentage thing. It's not a punishment thing. It's not a downgrade thing. If you didn't get all the points, it's because either right there on your document or right now in class, I'm telling you some things I need to see in the homework to get all the points. And you absolutely, hopefully I made this clear on a lot of your documents, but even if I didn't say this to you personally on your document, if you got some points, if you got most points, but not all you're going to have to do is follow the advice I'm about to give you for this class period, and then just revise and re-upload it, and you will get all the points. And that will be true about homeworks in general until I say otherwise. So everything you're trying to turn in a first draft in time for class. By turning in a first draft, you get a bulk of the points right away. Then you get the rest of the points for making it perfect according to instructions. So, okay, hopefully that's clear. You're not cheating if you revise or re-upload. You're doing what I would like you to do. And you're not cheating if you talk to other people and help other people. That's awesome. You're not cheating. You're not cheating if you use the web, if you use other resources like Khan Academy. None of that is cheating. As long as everything you write down, by the time you write it down, you understand it. And all of this is to say that's partly because we're not assigning a textbook. There's no source that I'm expecting you to have to read. And you might have already noticed that I assign the homework and then we go over it. So you're being asked to try to figure out the homework on your own and do your best attempt at the homework on your own first. Then we go over it. Therefore, please understand that the score that you get when you first try it is not a final score. So it goes both ways. Okay, But please understand that more and more as we proceed through the class, you're going to be looking at assignments where you're like, wait, did he go over this yesterday? And the answer is no. And then you might be like, wait, am I supposed to have read chapter 6 in the textbook? No. The assumption is that we're learning how to do what we don't know how to do. That's what real science research is and real science is. So of course, if you keep paying attention to class, the assumption is you would have a clue how to dive into the next homework, but you're going to be figuring things out on your own the first time, and then we go over it. Okay, I think that's, I'm looking at the chat. Hold on. Did you have class? Oh, that's a really good question, Gabriella. Really good question. And not always, and in fact, honestly, as the course progresses, I spend less and less time saying these kind of things and more time just like going over problems and doing physics. And as the class progresses, the homeworks get harder and bigger and deeper. So they actually get less and less frequent as the class progresses. Like right now, yes, there was a homework due today and there's a fresh new homework due on Monday because they're not that time consuming yet, I think. So to be extra clear, yes, there was a homework due today. Yes, there's a new homework due Monday. But your first priority, even before you get to the homework due Monday, is you should try to revise or re-upload whatever you did today, if you did it already, to get all the points. But and yes, for a little while, there'll even be a homework due Wednesday, but pretty soon we're gonna have a catch-up day number 1. And then number 2, pretty soon the frequency of the homeworks is going to slow down and it'll start looking more like once a week. And then it'll be even less frequent. Like the homeworks will start spreading out because they're going to be bigger and bigger and there's more and more to say about them. So no, at the beginning, there's a few of them, but in general, on average, it won't be 2 homeworks a week. It'll be more like 1 that we're all. And so if you want to, did that answer the question? Let me know if that answered the question. That's a great question. And if you could, great, thank you. So, and notice, so Gabrielle, just again, we're going to talk about this in a second. Notice that in terms of participation points, she just got as long as he submits into the appropriate portals, like there's one portal that basically says, please go back, which kind of means like slow down, wait, stop, like go back to what you were saying a second ago. Hold on, I'm not ready for you to go on it. She can submit that question that Gabriella, and I'm just using her as an example. The question she just put in the chat, actually, let me back up and be super clear. Tonight, there's game turn 2 is due tonight at 11:59. The only things that are ever due at like 11:59 are these daily participation turn assignments. So that one that's due at 11:59, Gabriella, as an example, she can write in that one that's due tonight. I asked a question in the chat about how often homeworks are going to be. Okay, so she could submit that for her 5 points for tonight at 11:59, and she'll get a quick. It takes her 2 seconds. She'll get a quick thank you from me, whatever. She gets the 5 points. Boom. But also, then she can take that exact thing and she could submit it into any other portals that it applies. Like if there is a portal, I think there is a portal for using the chat or something. She could put it in that. Or there's a portal for please go back, i.e. like slow down what you're saying now. Hang on, I have a question. She could put it in that. The same exact thing. She can double dip. She should double dip for extra points. Plus then, and I'm not trying to drag this out, but I just want you to see how this works for 2 semester. Then I answered and I said, does this make sense? And she said like, yes, thank you, which means I can go on now. So she can submit that in the portal that says closing a conversational loop or a conversational path. Some of the titles are very cutesy and not clear. So you have to like read the instructions of what they mean. But anything that applies anywhere, you can triple dip, quadruple dip, anything that applies, you could put it in. Okay. And that includes for the everyday regular turn, whatever you did, you just could go in there. Okay. But so it was a good question. So the homeworks will get less frequent as we go. Of course, I'm going to be spending more and more time just talking about the homeworks. The other thing I wanted to say about, okay. So today I'm going to start, sorry, someone's here. I'm going to start going over homework 1 today in a minute or 2. And I'm going to start showing you what I expected for homework 1. I'm going to show you how to do homeworks and exams with the 5-step method. It's what I expect going forward for everything. The easier homeworks are practice for the harder homeworks. Harder homeworks are practice for the exams. The exams are practice for what I think you're really supposed to be thinking, like if you're ever submitting an article to a physics journal or doing physics research or science research in general. So it's all the same method. Many of you already understood or noticed or tried on your own to do last night's homework. Like you found the 5-step method in the tools section, which is great. And I saw that many of you already tried to do the 5 step and did very well with it, as a matter of fact. Of course, I never explained it yet. So you couldn't have done it perfectly. I know that and you know that. So today, when I show you what it means to sort of do it perfectly, or at least, completely, if you're sitting there thinking, oh, I get it now, but like I didn't know this last night, like I know. If you get it now, that's totally cool. So you're going to go back and revise and re-upload, and then you'll get all the points. And now you know always going forward. I hope that's clear. So again, the trade-off is you have to think of things before I explain them, but therefore you always get more than one chance to get all the points. You're not punished for not, but you get a lot of points for trying first. That's the whole idea. Therefore, last technical point, and then I'm going to move on. I'm going to start going over this homework with the method. Last technical point. Because I'm into revisions and re-uploads, I want to make clear how you do that in Google Classroom in case some of you haven't used it before. It's a little bit like not obvious. Wait, I'm just looking at the oh, wait, I'm looking at the chat. Sorry for the draft. You're right. Oh, great question. Karen's question. Okay. For the draft, does that mean technically redoing the homework to gain all full points by the end of the day? No, it doesn't have to be by the end of the day. Right. It's if anything, it's for the next class. Sorry, did I read that out loud? Right. When you redo a draft, it does not have to be by the end of the day. The only thing that has to be that night is these little participation game turns. And the reason for that is because, first of all, they're so quick. I don't mean them to be stressful, but second of all, because I want you to do them before you forget like what you said in the class that day. But no, the regular homework, redoing drafts, resubmitting drafts, you could do for the next class. And honestly, to be really honest, you should do it for the next class so that you don't fall behind. But once you have a draft that's in on time and you've gotten most of the points for, then I'm not holding you to the clock any longer anyway. It's honestly like you could actually submit a redo 2 weeks from now and I'll get the notification and it'll be fine. I think it's not a great idea for you because then things start going out of order and blah, blah, blah. But there's no deadline until I say otherwise, until we get like deep into the semester. There's no actual deadlines on resubmitting. I just would highly suggest that you get that out of the way before you move on to the next thing because it'll start piling up. But so that's a great question from Karen. And if Karen, if you could just let me know in the chat or with your board, like, did I answer? Or is it clear what I'm answering? Awesome. All right. Awesome. So that's closing. So she just got like triple points for that. Blah blah blah. Okay. But these are good questions. So what was I gonna? Oh, so. For uploading a second draft, this is important for everybody because what I'm about to say applies. Let me just change the view of the screen. It applies. Oh, and thank you, Joran, for showing video. Thank you, Emanuela. Thank you, Joran. Thank you. Sorry, and thank you, Andrew. Tell me in the private chat if I'm doing it right. But Andrew, or like phonetically doing it. Anyway, thank you guys thank everybody for showing video. Who is showing? I just lost my train of thought. Oh, the thing I'm about to say is kind of important. I almost feel like I should write it down or screen share, but tell me if you miss it. But if you're ever uploading another draft of something, it's really important to me that the old copies stay there. So this applies in 2 different scenarios. Number 1, regular homework. Like today, again, a bunch of you submitted already homework 1, and a bunch of you got like fast feedback that will make more sense to you as I'm proceeding through the class. What if you submitted and you got any kind of points? Like a lot of you got like 16 points out of 20 or 11 or 18. Like, first of all those scores are good. Don't think of them as percentages. If you got more than 10 points, it means we're in business together. We're on the same page. You're in it with me. You're on time in the course. You're good. It means I'm about to show you today a more specific way that I want you to present the homework. But it doesn't, if you got 16 points or 11 points, that doesn't even necessarily mean you got any answers wrong. We're going to find out about that in a minute. But if you want all the points, yes, you're going to want to upload a new draft of it, and you're going to want to keep the old draft, partly so that it's still clear that you did the old thing on time. You don't want to like shoot yourself in the foot. Second of all, you want me to see how much work you're doing. You want me to see, oh my God, this person is like doing draft after draft. Like, it's good in every way for you to keep your old draft. Second of all, I want everybody to get in the habit with physics, especially. Even when you think you want to just think of everything as constant improvement and not think of your old things as mistakes that need to be obliterated from the universe. We'll talk about more about that later, but you don't want to disappear your old self. You just want to build on your old self. So you want to keep the old draft up there for regular homework, but also more specifically, let's say, for example, Durant is showing video, I think, for the second day. I believe he showed video the other day. So the other day he showed video. That means when he has a moment, and if I'm wrong, forgive me, but I assume you're going to show it again. So just using it as an example, the other day, let's say Durant showed video. So first of all, in the game turn, he could like write in that like today, the way I participated was I showed video. He could write that in the 5-point turn one thing. But then also he sees the portal that says video. So he uploads a screenshot into video and uploads that like the other day and gets the 7 points or whatever it is, a lot of points for that. Now today he wants to say, again, I'm showing video. I want more points. Yay, good. You should get more points. So what does he do? I want him to keep the old screenshot already up there. I want them to stay up there so that if he keeps doing this every day, if he like for 15 days in a row, or Emanuela, anybody, if you're showing video like 15 days, I want to see 15, we can both see 15 screenshots up there. So we all know immediately, like he should be having a total of 15 times 7 points or whatever, which is really true. Like a lot of people build up a lot of points just by doing these things repeatedly. So he doesn't want to tear down the other attachments. So the thing I'm dragging out way too much, whether it's regular homework or game portals, what Google Classroom needs you to do is when you're going to put a new attachment, I mean, many of you know this already, forgive me, but what you have to hit, first you hit unsubmit. That confused me for a long time. It sounds like it means you're taking down an attachment. You're not. It just means you're officially saying, wait, hold on, I want to do something that's no longer like my final copy of this assignment. So you hit unsubmit. Then you add new attachment or attach a file or whatever. And then you hit submit again. That way I will get a notification that you just like built on your old thing. I'll get the notification. I'll see all of it there. You'll get the more points. You won't lose the old points. So you have to unsubmit, reattach, and submit again. If that's not clear, please tell me in the chat. Oh, Andrew. Okay, great. Thank you for the direct chat. Great. So if that's not clear or you need more help with that, tell me in the direct chat or somewhere. But that's what we do. Okay. Having said all that, I think we're going to move on to going over homework 1. We're going to go over homework 1 now. I'm going to warn you in advance. It's going to take me a super long time even to do question 1 because I'm trying to show you exactly what you need to do. Then once you get what I'm saying, then I'm just going to do answers for the rest. Then we'll move faster and faster. But I want to make this clear what I'm looking for. So I'm about to turn the page. We're about to go over homework 1. Can I just get a show of electronic thumbs or electronic hands? Like, are we clear what's going on and what's about to happen? Like, is everybody okay for me to move? Thank you, Emanuela. Thank you, Sydney. Thank you, Yaneli. Thank you, Roger. Thank you, Samantha. Thank you. Okay. Thank you, Ariana. Thank you, Gabriella. Thank you, Erica. Thank you, Genesis. Thank you, Sydney. Thank you, Sonam. If I missed someone, I'm sorry. Thank you, Kaya. Thank you, Gabriella. Okay. And thank Brian, Drawn. Awesome. And any of you who never participated before, the thumbs up you just put totally counts for your 5 points tonight. Okay. Awesome. Thank you. So I'm going to, okay. Whoop. Okay. So we're going to move to homework 1. All right, so here's homework 1. And I'm changing the view on the screen for a second. Sorry. Okay. Now, so again, this is like what ideally like I'm looking for from you, how to do homework in general and how to do exams. It's like everything. And it again, especially if you have me next semester, it's all the same for Physics 204. So please bear with me if this feels like boring. It is boring, but so first note, I have a fresh sheet of paper, right? I'm not doing the homework on the actual sheet. If you did the homework on the actual sheet, which some of you did, so you only got 11 points, I'm not yelling at you. I'm not criticizing. Like you now you know, so just resubmit. But you want everything is as though it's its own blue book. You treat my questions like they're a separate document. So you take out a fresh sheet, and you're okay, a fresh sheet you can write or type. So okay, it says at the top NumberLine, and it says my name, Yaverbaum. Oh, sorry, Yaverbaum is my name. Okay, and now notice everything I'm doing in brown here is me talking to you. Well, that's not quite right. Yeah. Hold on a second. Hold on. Okay, when I'm writing in red, this is me writing to you. I'm saying that, but then everything else, brown, blue, black, is like what you would, well, anyway, you would take out a fresh piece of paper and you would first do step one. Oh, and I'm sorry, sidebar. There's in the tools section. I mean, obviously many of you noticed this, or maybe I did remember to mention it last week. In the tools section of Google Classroom, there's a document called 5-Step Method. It's just a one-page summary of everything I'm about to say. It's just like to help you remember, but I'm going to explain it now in broader terms. So this is the 5-step method that's expected for all work. It's what you're expected to do for me. It's how you get all the points. It's also how it's my grading rubric for how I give you the points. So step one of everything is diagram and fact pattern. That means you're going to provide a picture of the situation. If I already gave you a picture in the problem, you might be copying that to a large degree. That's fine. But if I didn't give you a picture, you're all the more important that you're making a picture. We need every physics problem to start with a picture. It's not just math, it's physics, it's about space and time. So we need a picture. If I already gave you one and you're largely copying mine, that's fine, but you're not electronically copying and pasting it. You're doing it yourself for 1,000 reasons. Can you use Google Draw or like a stylus or that? Sure. I don't care if you use a computer, but you're doing a diagram. Couple of hints about the diagram. So here you see I've made a diagram here, right? And it's very similar to the one that was already presented in the sheet, but it's not exactly the same. And of course, it's very similar because I'm the same person that made the sheet. But in your case, yours will look not the same as the one in the sheet. Now, a couple of things to notice, and I hope you're sort of taking notes on this. And again, if you're a quiet person, I'm going to say a lot of things now that I'm not necessarily writing down. So if you take good notes and if you write down anything that I say right now that's not literally on the screen, take a screenshot of it and submit it to the notes portal, and you'll get points for that. Because what I want to say now, for example, is this diagram that you present in step one is not a graph, is not usually a graph. It's usually not a free body diagram, if you remember those from high school physics. It's not, in other words, a specific type of technical diagram that helps you solve things. It's just a diagram of the facts of the situation. It's not a solution yet. It's a problem, if you know what I'm saying. Okay. So here, like, this is not doing anything for me, this brown picture. It's not doing anything to solve. It's presenting what the situation is, and it's fully labeled. Ultimately, the key point of a diagram, and it says here off in blue, it says labels equal constants and variables, whereas facts, got it. Good. I'm just responding to a direct chat. Okay. Now this is a little harder to see. Now, of course, let me back up for a second. I'm dragging this out today. I know this is going to be boring, and I apologize. I'm going to be spelling out exactly how you show work for a problem that I know many of you did in your head. I understand this problem is comparatively not that difficult. I'm not trying to insult anybody's intelligence. I'm hoping the problem, at least the very first one, wasn't that difficult. In fact, let me just get out of the way. I believe the answer to the first problem, the first question on the homework, is 21 feet. I believe that's the answer. So if you got 21 feet, good, you're on the same page as me, but don't now stop paying attention just because you got the right answer. Because what I'm trying to show you is, I'm trying to use a case where you already know the answer to show you what you have to do in the future, particularly when the answers are harder to come by. So you're going to draw a picture, and the main purpose of the picture actually is that in the future, you'll know you've done a good picture if every constant and variable, if every letter that you're ultimately going to be using in all the equations and all the math that you use to solve, if every letter that ever appears in your math first appears as a label in your picture. That's really the idea of the picture. Now, it's a little bit harder to see that here because we've just begun physics, so we don't have letters and equations and stuff yet. But for example, like I put like x1, x2, x3 in this picture here, like displacement 1, displacement 2, or whatever. That's the kind of thing. That's really what the purpose of the picture is so that once the math starts, we know what every letter means. Its definition came from a label in the picture. So from here on in, so the key to the picture is the labels. The labels are the constants and variables that you're going to use in the math to solve. And then when I say diagram equal, I mean DFP, step 1 equals diagram and fact pattern. What I mean by the fact pattern is facts that you write underneath the picture. Usually in the future, those will be specific numerical values. So as the physics problems get more sophisticated, you'll see a picture that'll have things like X and T, or yeah, X and T or something in the picture. And then underneath, it'll say something like X equals 3 meters, T equals 5 seconds or something. So you got a picture that labels the letters, and then you've got letters assigned to numerical values underneath. That's what I mean by diagram and fact pattern. That's what you do first. From now on everything. And even if it involves a lot of copying what I already did. So similarly, if on your homework at all, even if you look, you might have worked really hard on your homework and you might have all correct answers, and I commend you, and I see that, and you might have done it on time, hence you got tons of points. But if I just scrawled if you just saw a quick note at the top that just said step 1 DFP, that's just my way of saying I need a diagram from you. So resubmit with a diagram. And the reason you didn't get all the points is that there isn't a diagram. Same thing will often, if it's an exam, I'll be more specific, like DFP -2 points or something. Like on an exam, I'll try to be clear about exactly how many points you lost because of that. But on homework, I often won't do that. I'm just going to say, this is what's missing. If you want more points, add this, resubmit, and we'll both be good to have all the points. Okay, so this is the grading. It's what you need to do to get points. It's how I label what's missing. So step 1 is DFP, diagram and fact pattern. Okay. Then, and stop me if there's any questions. I'm just looking at the chat. Is there any questions? Okay. Okay. Then, also, well, okay. So then you do step 2. WIQ. What is the question? Now again, no, I'll try to change that to red. I want to make it, this is like a little bit unclear, but I'm not saying that a reason I'm doing this in red here. In fact, I'll do it like this. The reason I'm putting it in red and everything is that when you do your homework or you do your exams, you don't have to make a big thing. What is the question? I'm not saying to do that. I'm saying provide what the question is. And sure, off in the right, in the margin or something, you can make a little label that says, here's step 3, Haberbound. Here's step 3. What is the question? You can do that as you go. That will make my life easier. It'll also be a good checklist for you. It's almost like you're just checking the grading rubric as you go to make sure you've got all the elements. You certainly are encouraged to off in the side label, like here's step 1, here's step 2, because that's what I'm always looking for. Step 1, step 2, step 3, step 4, step 5. But you don't have to make a big production about that. What you have to do is the actual steps. So what your homework will look like is now here, it says question 1, right? You've just put the diagram. Now it says from question 1, from t equals 0 to t equals 8, distance equals question mark. Like what's in black is what you're writing. Now let me pause on that for a second. Notice, I am literally, this is like slightly unusual until you get used to it. I'm saying you can't write your answers on my question sheets, but I'm saying you want to make the question clear every time you're answering a question. Furthermore, I'm saying don't copy and paste my questions. Like don't copying, and don't even copy the exact words of my questions. I'm saying this now is your job to take whatever the question is and somehow rephrase it, somehow simplify it, somehow put it in your words enough to make it clear and direct and simple, and make it clear to me that you really understand the question. Now, often, as we get more and more into equations and stuff like that, often, like it will be something like at t equals 0, comma, v equals question mark. Like it doesn't have to be elaborate English. It just has to be clear. It might be letters and symbols. At t equals 5 seconds, comma, v equals question mark. Like that would be an example. So I'm trying to show you here, like in this case, like again, we don't really have equations and letters yet. We have English words right now. So I'm using English words. So I wrote like from t equals 0 to t equals 8. Sorry, from t equals like 0 seconds to t equals 8 seconds. Distance equals, like that's what you would do. You don't have to do it that way, but just what I'm just trying to, because I will admit, someone in the other class like raised a question, and for some people, what I just wrote here is even more complicated. You might have even understood the original question, and you might not even understand what I'm writing here. I'm just trying to show you that it's different. For the original question said, what distance is covered by the instructor in the entire 8 seconds journey? Do not just copy that word for word, because that gives me no evidence, and it gives really you no evidence that you actually have assimilated the meaning of the problem that you have to solve. You want to show that you know the problem. Okay, I'm dragging this out, but it's super important to do that. And when I say it's important, all of this I know sounds like kindergarten. I know that if by the time you're in my class, you've done some amazingly hard science and math work for years and years. I know you all know how to be math and science students, and you're advanced. And all of what I'm saying now sounds like I'm bringing you back to 7th grade or kid, but I promise you it's not meant to be an insult or condescension. What this is all about is a method for knowing what to do when things get hard enough that you don't know what to do. I mean, I won't drag the point out right now, but I'll literally tell you that it took me till the second time I was in graduate school to really understand how crucial it is to take a question and rewrite it in my own words and present what the actual question is before I go any further. Like literally, it was an issue in my dissertation, like whatever. So please don't take this as an insult. Take it as advice for hard physics. So you write down the question in your own words, like I did here. So that would be, wait, I'm changing screens again. So that would be step 2 is what is the question? If you don't have the question, and don't think that if you've made, when you start it, whatever, you get the point. You got to make the question explicit. It's a step. You can't just think that I could infer what the question is by seeing what your answer is. It doesn't work like that. So if I wrote on your homework, WIQ, that means resubmit and make, okay, you get my point. So that was step 2. So now comes step 3. Let me just, yeah, I'll change it to blue, red, so it's clear. I think from now, actually I only used brown from now on, but whatever. Step 3, GDP, which stands for General Definitions and Principles. Now, this is where I actually think it does start getting interesting in a way. So this is your step 3 out of 5. You're going to do step 3, General Definition Principles. That means, well, here we go. Well, oh no, okay. What that means is things that you know before the problem started. So let me back up for a second. Yes, I know that when you were in 7th grade math or something like that, you probably learned when you were doing word problems for the first time, which is a lot of physics looks like word problems from 7th grade math. Hold on, I just lost the screen. When you were first learning how to do word problems, they probably taught you things like write down what you know. I think there's like a WYSIWYG method or something. And people here often like write down what you know and then write down what you're looking for or what you don't know or what you're trying to solve and then link the two. I agree with all of that. And I know you've heard it a million times. First, write what you know and then write down what you're trying to find out. But now I'm trying to show you that there's like actually a big distinction in there's different thing. There's two different ways of knowing something. Well, there's more than two, and I think you talk about it a lot in lab actually. But you've already written down in step one what you know. In step one, you've already written down what you know about this particular problem. You've written down the facts of the problem in step one. Now in step three, I'm asking you to write down things that you know that were true that you knew even before the problem started. That's a different kind of thing. I'm asking you to write down things that are true in general in the universe, definitions, laws, principles. Often, once we're rolling, these will look like equations. I mean, they will be equations. Some people might call them formulas. I don't like calling them formulas, but they're equations. It's now, and since they're often written as equations, I want to talk about equations for a second with you. So first of all, in this problem, in this homework, you're writing down the definition of distance, right? Like what you already knew in step one is, no problem. Nope. Oh, sorry. Wait, sorry. I'm doing something in the direct chat, and sometimes the direct chat is, hold on. Sorry. Hold on. Sorry. There's something the thing with it. Okay, sorry. That was okay. In this example, we were told certain distances in the fact pattern. We're ultimately going to solve for a certain distance here in this problem. But what I know, even before I began the problem, is how distance is defined. That's my general piece of knowledge that I need to apply to this problem. Again, I know it's not that hard in this case. That's why we're practicing it now. So I write down a definition of distance. Where did I get the definition? In this case, I got it straight from the sheet, right? Oh, and I should say, any definition you're ever writing down, because a lot of this is about definition, should be a definition that somehow came from the class. Like even if it comes from the sheet that you're working on right now, like if you just grab a definition from the internet and it has nothing to do with anything we've ever talked about, that's highly suspect, highly sus. But here, distance was defined in the sheet. So I'm writing down a definition of distance. But notice even here, I'm using my own words. I'm showing that I understand it. Now, again, in general, these kind of definitions are ultimately going to be phrased as equations. So there's not going to be as much ambiguity, or it'll be more clear. So I wrote down here, distance equals total space traversed throughout a journey, all the space that's accumulated independent of direction. That's like a rephrasing of what you were told in the sheet. Notice that I wrote it with a triple equal sign. I want to introduce you right now when I say it's really important in physics. Physics is all about equations ultimately, as you know. But what I did not know for a long time until I did is that there's two types of equations. And it's really helpful in physics to keep them straight. There's literally two types of equal signs. This you might not have known in high school, or maybe you didn't know in biology or something. Triple equal signs do not, by definition, equal double equal signs. A triple equal sign, so I'm telling you, this is where I'm in the brown here, down at the bottom. Triple equal sign means equal by definition. So you might want to write, I'm going to say that again. Triple equal sign means equal by definition. Double equal sign means equal by discovery or inference or computation or something, but say discovery. So what do I mean? I mean, from here on in, you already saw in the sheet, like we are saying average speed equals total distance over total time. And then soon we're going to say, like, or we do say in the sheet, average velocity equals displacement over time. And pretty soon that gets captured as an equation. V bar equals x minus x naught over t. right? So these are gonna start looking like equations because we're just gonna substitute symbols for the English words. So a lot of times in this class, we're gonna have this thing, this example. A lot of times in this class, now again, I'm writing, sorry, I'll write in red. So you wouldn't put this literally in your homework. This is me being a teacher to you. But we're gonna say in this class a lot. So this is an example. I'm not literally teaching this equation right now, but this is going to be a very common equation for us. Average velocity equals displacement over time. But notice it's a triple equal sign because the point is no one ever discovered in a lab that average velocity turned out to equal displacement over time. That discovery never occurred. That experiment was never done. And the importance of, and furthermore, therefore, no experiment could possibly ever be done to modify or improve on or disprove that equation. That equation did not come from the lab. It didn't come from discovery. It didn't come from circumstances. That equation, average velocity is equal to displacement over time, is literally just a definition. It's literally us just saying, oh, I'm going to look at, I see something in the chat. I'm going to answer in 1 second. Let me just finish this up. But awesome. When we say average velocity equals displacement over time, we're just saying that from here on in, instead of saying displacement divided by time every time, we're going to save time by using the word, by making up the term average velocity and substituting it for the mouthful displacement over time. You'd be shocked. Well, some of you might be shocked to know a ton of physics equations are just that, just definitions. And it's really important to know when you're just writing down a definition, when you're writing something down that's equal by definition, it's super important to know that because definitions are never wrong. They're absolutely, if they're correct at all, they're absolutely correct, right? Just like a square is never a 5-sided figure. Double equal signs. So you might say, well, why don't we just do everything with definitions? Well, the disadvantage of definitions is they don't tell you anything about the world, right? Like really, the power of a definition is if it's wrong, if it's right at all, it's never wrong. But the disadvantage of a definition is it doesn't tell you anything about the world. Like literally, if I tell you, oh my God, I just saw a 4-sided square, you'd be like, yeah. Or if I'm just like, here's my big discovery, all squares. It turns out every single one of them without exception is 4-sided. You'd be like, that's not duh, that's just what the word square means. Like you haven't told me anything, information. Double equal signs are what give us information about the world, but they are subject to being wrong. So so physics is full of both, but it's really important to know which one we're doing which. I'm going to get the chat. I'm not forgetting that someone's in the chat. I'm just going to wrap this point up and then the chat. I'm saying therefore, in step 3, what we're looking for, generally speaking, is triple equal sign kind of truths. Truths that are just true even before the problem starts, and we write them down, such as distance means this. And now, then we're going to be ready to go on to step 4 and start solving the problem. I'm going to pause for a second because of the chat. Hold on 1 second. Oh, wait, this is a great question, actually. Hang on. In fact, I want to think. I mean, it's not like the first time it's ever come up, but okay. And I'm not going to now. This is direct. I'm not going to use a person's name but I will say it's a great question, and I think everybody could benefit from it. So, I'm just going to so I'm going to rephrase it in a second. So I'm not trying to, but whatever. It's a great question, and the person should submit this question for points. And if I answer it, and then the person says in private chat, like, "Yeah, you answered it," that person should submit that for the closing conversational path points. Yeah, okay. It is a really good question. All right. So the basic question is like, do we actually have to do the 5-step method in order? Like, because a lot of people like writing down like equations or general definitions like at the top of their page, especially if it's an exam. Like a lot of people like, putting what they know like up at the top and then proceeding. So the good news is I love the question, and the good news is I totally hear what you're coming from. And the good news is, yeah, if it helps you with an exam or whatever to like write stuff at the top first, that's totally okay. But you still have to do all these steps in the order, unfortunately. Like, I'm glad you're asking. Like, because I need to know what you're using when. So yeah, it doesn't throw me off to have stuff happening before the method occurs. And it's okay to even have stuff like throughout the method, but the steps themselves, like basically, once I see a diagram and once I see what the actual question is, I'm like literally looking for, now I want to see what definitions the person's going to use or what laws or whatever. So it's okay if like they're already in a chart somewhere, and you can even say, like, say you have a box that I mean, this is really a great question. Say you make like a pretty, I should say, like a nice box at the top that has like the stuff that you care about. You can like label that, say, call it like figure 1.1 or box table 1.1 or something. And then when it gets to, and then like equation number 1, equation number 2, equation number 3 or something, when you get to this step, you can be like, for the general definitions, we use equation 1 from box 1.1. Like you can do that and maybe even draw an arrow or something. You can like guide my attention to where you've put it somewhere else. I'm okay with that. But just assume that right after you've done step 2, I'm looking for step 3. So you have to bring me there somehow. I hope that's clear, but like, so do whatever you want to make your life easy. But then, so again, this is all practice. And I learned this the hard way. This is practice for like a research paper where the readers of the journal articles are expecting a certain sequence. And even if your sequence is better, which it might be, it already sounds like it probably is, certainly for you, it doesn't matter. If they're expecting a certain thing, they get confused if things don't happen when they're expecting them to. So if nothing else, when you get to step 3, for example, refer me or repeat, or then you can copy and paste your own thing down there. Now, I'm going to pause for a second because it's really such a good question. I want to make sure. So that person that just asked me a question in direct chat, could you just put in direct chat if I answered it, like, okay, or if you have a follow-up? Awesome. All right, great. So you just got tons of points for that. Great. Thank you. No, awesome. Okay. Okay. So we've just done step 3. Now, again, I know I'm dragging this out. I won't drag this out every single time. But I promise you again, I could go on for, well, I am going on forever. Like I know these, well, I'll just keep going. So this is step 3. That's what you do for step 3. Now you go to step 4. Step 4 is PAW, Paul, particular application and work. So this is where, sorry, I used the word, I meant to say, this is where, and I'm leaving it, I'm not going to change all the, I think you get the point now that this. So this part in brown, again, like this is me talking to you. You wouldn't write all this in your homework, but this is where, so now step 4 is now where you're going to apply the general truth of the triple equal sign to the particular truths of the problem, and you're going to produce a double equal sign. The big transition word, the way that I generally know that you have transitioned from step 3 to step 4 is, this is not a rule, it's just a suggestion, is using the word here or something like that. Like as in this case. Like you've just above said distance means all the accumulated space or whatever in general. Now you're saying, okay, here in this case, if I apply that concept, so distance in this case is the absolute value of this chunk plus the absolute value of this chunk plus the absolute value of that chunk. Why absolute values? Because we're saying that distance by definition doesn't care. It doesn't matter whether you're going like forward positive or backward negative. So we're taking the absolute value of each interval, and each interval is a difference between two places, right? A space is a difference between two positions. Difference in math means subtraction. Just like sum equals means addition, difference is the word we use when we're subtracting. So I'm saying in the first interval, he gets from position +4 to position -2. So I'm literally doing -2 minus 4. Okay, like it's like if I say, how much did my son grow last year in height? How much did my son grow in height? Well, he started the year being 4 foot tall and he ended the year being 5 foot tall. So how much did he grow in height? He grew 5 minus 4, like duh, right? But I'm just explaining why sometimes it looks backwards to people that I'm doing like the final place minus the initial place because I'm tracking a difference. But I don't care actually which order I went in, so I put absolute values around. So the distance here is the absolute value of going from 4 to -2, plus the absolute value of going from -2 back to 4, plus the absolute value of going from 4 all the way, from 4 all the way to -5, right? So it's the absolute value of one chunk plus so I'm just applying the definition of distance to all the numbers, as many of you did in your head. And I understand that many of you did in your head. Nonetheless, you're writing it out for me here. I'll get back to that in a second. But right, so I got like 6 plus 6 plus 9. So then finally, in step 5, final answers. And obviously, most problems are much more involved in this. And there's going to be a lot more calculations there. Oh, I should also make clear, when the problems get more and more real, in fact, even here, I should have been tracking, like when the problems get more and more traditional and physics looking, this is where, like, you track your units, you do whatever kind of unit cancellation or stoichiometry is going on. If there's scientific notation stuff, you do that. Here's where you do the algebra, the trig, the calculus. Of course, in other words, step 4 is like really where a lot of work. It's like a big chunk usually of the problem is step 4, but it doesn't work unless you've set up steps 1, 2, and 3. So you do all the work here, and then finally, when you're done, you're up to step 5, final answer circled. And so if I add up 6 plus 6 plus 9, I get 21. Oh, and I see something in the chat. I'm going to get it in 1 second. And by the way, I'm totally psyched. Well, sorry. All right. I'm going to get the chat in 1 second. So step 5, final answer circled. Here's my final answer then. Now notice this, and I'm going to pause and do the chat and everything else. For the final answer, it's literally an answer to, it's an answer to the question that was presented clearly in step 2. So this final answer should be a complete thought, like subject and predicate, or noun and verb. And the verb in math and science is always equals, right? So, and it's a complete thought that answers the specific question, this specific problem. So there's some kind of condition. It's something like, in this case, thus, for 8 seconds of this instructor's journey, the total distance equals 21 feet. Like, my final answer is not just 21 feet. That doesn't mean anything. That's not an answer. The answer is total distance equals 21 feet. If this were a more traditional problem, it would probably look like an equation. My final answer will look like an equation, like x equals 21 feet. But two things. Number one, notice the equation will be preceded by some kind of condition, like at t equals 8 or something. X equals 21 feet. But also notice, even though the final answer is an equation, it's not a formula. It's an equation. It's a statement of thought. It's saying distance equals 21 feet. It's not something that you get out of a book or you memorize or you put into a book. It's a discovery. It's a result that applies to this particular situation. So what we've really done is gone from triple equal signs that we already knew to a final answer that is a double equal sign that literally links back to the original question in question 2. So this is now, and I'm going to get the chat thing. I'm totally not forgetting. This is like the model of what you would do for each question. I'm going to repeat it. Well, I mean, you're going to repeat it for all the remaining questions. You don't have to keep redrawing the diagram. That you certainly don't have to. As long as the diagram keeps applying, just keep writing. Step 1, for diagram, see above. Like, you have to address the need for a diagram, but just say see above, see above. So that kind of goes back to the other direct chat person's question about sequencing. So you're going to just keep doing this method each time. I won't right now. I want to just give you some answers so we're on the same page, but that's what you do in homework. I still have more to say, but let me get the direct chat before I forget. Okay. Let me also thank you. There's been a lot in the direct, not a lot, but like there's been great questions in the direct chat. And for the record, like each question that's in the direct chat has been like from a different person. So I really appreciate that. Like there's more varied participation going on right now than you might even know, but I know. So I appreciate it. It's like, it's not always the same person. I promise you. Okay. Okay, right. Great question. So I sort of partly already answered this, but right. So the person's asking, like, if there's repeat from one question to the next, do you have to repeat in your presentation? So certainly, if all of them are referring to one diagram, this is so classic in physics. If you have one diagram with one set of facts and then a bunch of questions about it, correct, you don't have to keep repeating the diagram and the facts. You can just keep referring to above. That is true. But if Oh, but there's more to this. Okay. But if the questions keep asking the same type of thing, right? Right, good point. Like if there's a number of questions about distance, do you still have to restate like the definitions and the general principles? Really good question. All right. So you definitely don't have to repeat diagrams. You could just keep saying see above. But similarly, step 3 is so important. Step 3 is so important as to how you do a problem that again, you can get shorter and shorter as you go. Like you can say things like see for general definition, see above. You can start referring to above. You can get less and less elaborate for sure. But you still have to address it. Like somehow, like you can't skip it entirely. Again, picture that this whole thing is an exam and I'm reading it. You can assume I'm reading your exam in the order that you give it to me. So if you give me a bunch of things right at the beginning, and then you and then you expect me to sort of use those things throughout, like that's great. Like, yeah, I'm with you. Like you've given me a paper. You're laying out things at the beginning. You don't want to say them a million times. So for the rest, you can always say, so see back to page 1. But you at least still have to do that, right? I can't get to a problem, and then you've done step 1 and step 2. And then for step 3, you just skip it entirely and go to step 4 because you assume that I assume that you're using the same thing as before. Like, how do I know that? Right. So, yes, you can make your life easier and easier as you go. You can assume that I've read page 1 when you're on page 2, but you still always have to address all of these steps. It is like a method. I mean, it's like yeah, I don't know how else to put it, but yes, you have to address each step, even if the way you address it gets shorter and shorter and more casual and more self-referential. So first of all, that's a great question. So please let me know, direct chat person in the direct chat, let me know if I did answer your question sufficiently. Okay, all right, awesome. Thank you. All right, awesome. That second, and I know we have like 11 minutes left. I want in the next 11 minutes, I'm not going to do this all again, and we're going to get used to it. There's still, again, oh, by the way, I haven't even, you can re-upload homework like 50 times. The next time you upload your homework for more points, even if you still don't get all the points, you could still do it again. The point is you want to get all the points. You can if you want to. Eventually, time will be a factor. But I want you to be in a position to be able to get all this 100% right, especially at the beginning, so that we can move on because it applies to everything. So don't, if if it takes a little while for this method to sink in, that's okay. I strongly believe from my personal experience, at least doing physics, that it turns out this method will serve you for a long time. I think it's really useful for 1,000 reasons, but I know that it's not exactly the way you did things in other classes. So it takes a little time. That's fine. And you can keep asking questions about it. That's fine. Uh, There's one other thing I was going to say. So in a minute, I'm going to turn the page and just give you answers now so that you can sort of know if you're doing the homework okay or not, like if you're thinking of the physics okay. But there was one other thing. Oh, yes. There's 2 ways to know. Okay, I'm going to add a page and write this is, hold on. Forget how to do this. Okay, sorry. Okay, I'm looking at the time. So we have 8 minutes left. All right. Two quick things about like how you even know if you're doing this right, which put it other way is sort of why you're doing it. Okay. First of all, you'll know in the end that you're doing this method correctly. If by the end, by the time you're done with a homework, whether it's easy homework or hard homework or whatever, or by the time you're done with an exam, if you have a document that is self-sufficient, meaning stands alone, meaning if by the end you could take your document and turn and hand it to another physics professor or put it in a journal and have it be read by a physics reader, if you could turn your document to someone who did understand physics, but did not know this class or the original assignment or the original exam document, if you could hand it to someone and they could follow it and see what you're doing from beginning to end and literally give you feedback, like peer review, like in a journal, and be like, oh, you're trying to solve this type of thing. Oh, I see. Oh, that's interesting. Oh, you do that. Oh, I don't think this works. Or I don't think that answer's right. Right. If you could, if it's physics that stands alone on its own and doesn't need the reader to know the original assignment, then it's good physics and you've done the method correctly. So put more practice. So partly this is meant to be practice for actual research, but more concretely, you're trying to give me a document that I can grade without having to flip through. Like if this were an exam, you want me to be able to grade your thing without looking at anything else. You want me to be able to give you accurate, fair feedback as quickly as possible without having me to cross-reference anything. That's the goal. So that's what you're trying to do, is present it all as its own package of physics. That's number one. Number two, you'll know that it's really working as our problems get harder. Like you're practicing this method now where you feel that you don't need it. I understand that. Like a lot of these answers you can get in your head, a lot of you. And so this is like, seems like a waste of your time. I understand that. And I sympathize. But two quick points. Number one, all the points that you get are for doing these steps, even if you get wrong answers, and you don't get points if you don't do the steps, even if you have the right answers. So you're not wasting your time. This is the work you're doing to get the points and get a good grade in the class. But second of all, what you're doing now, when you already see how to do the problem in your head, if you already see how to do the problem in your head, I want you to recognize that you deserve credit for that, for the fact that you can already see how to do the problem in your head, because it's not coming to you in a dream. It's not that the question is spontaneously generating automatically the answer. It's that it's that in your head, really quickly, you're going through a bunch of steps. When you think these things are easy, it's because you're going through a bunch of steps really quickly in your mind because you're really smart and you're really experienced, and you should recognize that. It's not because the question is easy, it's because you're smart, like for real, if you think a question is easy. So what you're doing now is taking a movie of the steps that had to have occurred in your mind, and you're putting that movie on paper, not just so that I can see it, but also so that when the questions start looking like classic standard physics problems, when the questions start looking like what some of you might have experienced in high school, or I certainly did in college and graduate school twice, when they start looking like, oh my God, I don't even know what this thing is asking. Like, oh my God, like what? I don't even have any idea what to do. I mean, I've certainly had that experience. I think some of you have, and it's an experience we don't want. That experience of what? I don't even know what this means. I don't even have any idea what to do. I'm trying to give you a method now that tells you what to do when you think you don't know what to do. And it won't work. This is a life raft that won't work unless you build it on dry land. You've got to see what steps your mind goes through when you do know something so that you know what steps to go through when you don't know something. And the real bottom line, I'm going to turn the page in a second. I know we have 4 minutes left. What I'm really trying to tell you is I know you've all been spending years and years showing your work. The secret truth is the work that you've always been showing in most math and science classes up until now has been from step 4 on. And so the reason it always seems like a waste of time is if you already know what work to show, then you don't really see why you're showing because you already see the answer. And if you don't know what work to show, if you don't know the answer, you don't know what work to show, so it doesn't help you get the answer. The real secret is that work does not start at step 4. It starts with steps 1, 2, and 3. And if you religiously start doing steps 1, 2, and 3, when they feel like a waste of time, your muscle memory will get you to the point where you're doing steps 1, 2, and 3, even when you don't know what's going on, and they will generate step 4 for you. I can't say more about it right now. I could, but I promise you do this when it seems like a waste of time. And then when you need it, it will work for you. And you won't be able to say, I have no idea what to do. You'll know at least 3 steps to do, even when you're totally confused. And you'll get points for all those 3 steps. And you'll be surprised. You'll see they'll generate 4 and 5, and you'll get it. Okay. So now, very quickly, because we have 3 minutes left, I'm just going to tell you the answers now for a lot of the sheet, just so that you have perspective, so you can see if you're doing it right or wrong. So if these answers match the ones you already got, then you probably don't have to change your work. You just have to redo it according to the step method and rehand it in for, okay? But if your answers are different from these, then you probably really have to rethink. I'm not giving you the last 2 answers because that's where we really have to think. We will go over them on Monday. So Monday, technically homework 2 is also due. If we don't get to it, that's okay. We're going to pause and catch up with ourselves. Just stay with me. Your first job is to revise this stuff, then go to homework 2. Again, whatever definitions you need for homework 2 are in the sheet. What am I trying to say now? But the last 2 bits of this require thought. I would recommend that the real thought should go into carefully looking at step 3. But up until the last 2, here are the answers so far. I believe the answer, the first one is 21 feet. Then x equals -9 feet. I don't care how you call words like displacement or distance, but make them as full sentences like this, like distance equals 21 feet for the first one. Then displacement equals -9 feet. Average speed equals 21 over 8 feet per second. Yeah, or, oh, sorry, you're right. You're right. Thank you. Is that in the direct? Thank you. She's absolutely right. Sorry. Thank you. Wait. I think you're absolutely, yes, you're absolutely right. I'm sorry. Yes, very good call. And the other class didn't call it, so you're smarter than the other class. Just kidding. Okay, and fractions okay, decimals okay. We'll talk about significant digits and what I expect with that later. Don't get bogged down in it right now. But those are the answers for those 3. Again, by the way, if you miss, class will end in 1 minute. So you go. I will stay if there's questions or whatever. If you don't catch all of this right here, of course, this is all in a PDF that I'm uploading in a minute anyway. So don't stress it. But these are the answers for the rest. I know class is about to end. Make sure you include your units in your answer. But yes, I don't care if it's a fraction or a decimal. I don't care if the fraction's reduced at this stage or anything like that. But these are the answers for those. I'm just going to turn the page again. You could stay for a second. I'll turn the pages back if you want. And these are the answers for those remaining. This is just so you can check your work. The last 2 will, oh, and any question you have about any of these, I'm not done. Monday when we meet, you can say, I don't understand how you got question 3. And we'll do that. We're not done with this. I'm just trying to help you progress forward. So I think that's, if you want me to, I'm going to change it. So it's 1:30. So I'm going to hang out in case there's any questions or anybody wants to make an appointment, whatever. But other than that, hopefully everything's clear. Have a great weekend. You could say goodbye in the chat if you thank you. I love the thing. See, you could say thank you in the chat. You could say goodbye. Whatever. And if you have a question, I'm right here. I'm going to turn off the recording, but I'll answer your question. Hold on. Great. Yes. Have a good one, folks. Hang on 1 second, Emanuela. I'm happy to answer. Stop the record.